So here our topic is standing waves. See, standing waves, for example, we are having one wave and that wave moving towards open end. So suppose we are having this kind of rope and we bind that rope with one rod and here. So some waves is operating from here and it is moving towards open end. And whenever this wave is getting to this point, that wave will be reflected like this. So we are having same phase now. Phases are same, but now just their directions are different. One is moving in this direction, another is moving in this direction. So this is the magic of open end. So that wave doesn't change its phase. So phase is similar in open end. But if this point is fixed, then phase will be changed then. Now, so if this incident ray, we are having y1 xt is equal to a sine kx minus omega t for positive x direction. For negative x direction, y2 is equal to xt is equal to a sine kx plus omega t. Now we have to write sum of these two, y is equal to y1 plus y2. Simply sum of these two, a common. Now sin a minus b plus sin a plus b. So complete formula for that 2 sin kx cos omega t. So in this equation 2a sin kx cos omega t. So this term is known as amplitude of our combination of waves, and this is the whole function of that wave, cos omega t. So this is amplitude, this is whole function. Now whenever amplitude becomes 0, that point is known as antinode. So antinode, at this point amplitude will be 0, and the node point we are having amplitude maximum value. So we have to remember these two things, antinode and nodes. So every wave has its antinode and node. So we will discuss this antinode and node into normal modes. Now for normal modes, we have two possibilities. First is nodes and another is antinodes. So nodes means a maximum and antinodes means amplitude will be minimum, right? So earlier we discussed that formula, that is 2a sine kx cos omega t. So from this formula we have sine kx, right? So whenever sine kx will be maximum, means sine kx is equal to 1 for maximum, sine kx is equal to 0 for minimum. Now for this maximum, kx is equal to, for this minimum kx should be equal to, see kx, when this becomes here 90 degree, pi by 2, then 3 pi by 2, further here kx 0, 0 after pi, then after 2 pi, 4 pi, right? So 0, 0 and 90 degree, so that starts from n pi. So this is general form to take this value as 0, where n is equal to any value 0, 1, 2, so on, right? Similarly kx is equal to n plus 1 by 2 into pi. Similar here, n is equal to 0, 1, 2, so on. If we are taking 0, then pi by 2 will be 1, right? Sin pi by 2, 1. Now this is kx. Now k formula is 2 pi upon lambda, x is equal to n plus 1 by 2 into pi. Similar here, k value 2 pi upon lambda, x is equal to n pi, right? Pi gets cancelled out, here pi gets cancelled out. So we are left with lambda formula here, lambda is equal to 2 into x upon n plus 1 by 2, correct? Here lambda is equal to n, here lambda is equal to 2x upon n, correct? Now these are lambdas, we know that now n formula, correct? Now see, this is, if we take x as L, so our whole length of our wave is L, then L will be n plus 1 by 2 into lambda by 2. Similar here, x we have to take L and subject that, so then will be n lambda upon 2. Simple, this is length. Now what we have to do, we have to find frequency for nodes and antinodes. So to find frequency, earlier we discussed that formula is C is equal to F lambda, right? We know this formula. Now from this formula we have to find frequency we denote with nu also, right? So subject nu, then nu will be is equal to C upon lambda. Now C is our V, so we can write C instead of V, we can write V instead of C, okay? Now nu is equal to V into V upon lambda, actually V upon lambda. So here V upon lambda, now lambda, this comes to upside, so n plus 1 by 2, and this comes to downward, so 2 into L. So this is whole equation of frequency. For this, now again what we have to do, this is our lambda, right? So this is lambda. Now again nu is equal to V upon lambda, so V into n upon lambda means 2 into L. So this is frequency for antinodes, this frequency for nodes, right? Now we know that n having different values. For first fundamental value, means here we have to start from 0. So it's for example nu 1. So nu 1 is equal to 0. So V upon 4L, simple. Then so frequency here combination. Now n is equal to 1. N is equal to 1. When we put 1, it will be 3V by 4L. When n is equal to 2, it will be 5V by 4L and so on. So that means 1, 3, 5, 7, 9, so on, like that. So this is fundamental, this is first harmonic, this is second harmonic, third harmonic, right? This is fundamental. Now for this, nu values are, when we put here, 0 means 0, we don't have to write it. So first start from n is equal to 1 here, so V upon 2L. Then second V upon, means 2L upon 2V upon 2L. Then third 3V upon 2L. Then 4V upon 2L. So here combinations are 1, 2, 3, 4. First fundamental harmonic, first overtone, second overtone, third overtone, first fundamental, second fundamental, third fundamental, fourth fundamental. So if we are using fundamental, so it will be first, second, third, fourth. And if we are using overtone, so this is first overtone, second overtone, third overtone. Similarly here, first fundamental, second, third, fourth. This is third overtone, fifth overtone, seventh overtone, like this. So nodes and antinodes. Now I am drawing nodes and antinodes for particular some string, right? So if you are having fixed ends, so these are fixed ends, so always for fixed end it starts from antinodes, right, like this. So this is antinode, this is nodes, now that, right? So start from antinode, these are node, antinode, node, antinode, node, antinode, node. For every node points there is maximum amplitude. For every antinode point there is minimum amplitude. So this is for closed pipe. Now one end is open, one is closed. For that we are having, whenever we are having open end, at that point we are having maximum. So it starts like this, right? So this is our maximum, this is open end, this is closed end. So it starts from node, antinode, node, antinode, node, antinode, node, antinode. So here and A, right? If we are having both the open ends, so for both the open end, I am going to draw here. Both are open, right? So on the open end, we are having maximum value. Remember, right? So this is maximum. This is node, antinode, node, antinode, node, antinode, node. So this is for both open end. This is for both closed end. This is for one open end, right? So after that, we can find the frequency of this node antinode. First frequency is of it is of node, then this is first, second, third, fourth. If antinode, first, second, third, fourth. We can find for any these cases, both closed, one open, both open. So that is the whole topic of normal modes.